Fine. Let's start. Number 10. The Nemesis Star. Somewhere in the 1980s, two paleontologists did something that should have been harmless. They made a graph. They took the fossil record, every great dying that we could date with any confidence, and they plotted the mass extinctions across hundreds of millions of years. And what came back wasn't noise, it was a rhythm. The big die-offs seemed to repeat on a cycle of roughly 26 million years. Like a metronome buried in the rock. Now, life on Earth is messy. Extinctions are supposed to be random. A wandering asteroid here, a chain of volcanoes there, a slow shift in the climate. Chaos doesn't keep time. So when the graph showed a beat, a steady pulse of death every 26 million years, it left a very uncomfortable question hanging in the air. What kind of clock could possibly be ticking on that scale? In 1984, a group of astronomers offered an answer, and it's the kind of answer that lodges in your spine. Mark Davis, Piet Hutt, and Richard Muller proposed in the journal Nature that our sun is not alone, that it has a companion, a second star, faint and cold and so far out that we've simply never noticed it, swinging around the sun on a vast, stretched-out orbit that takes tens of millions of years to complete. They called it Nemesis, after the Greek goddess of retribution. Because every time this hidden sibling swings back in toward us, the idea goes, it plows through the Oort cloud, that immense shell of frozen comets that surrounds the entire solar system out in the dark. And when it does, it knocks a storm of comets loose. Some of them fall inward. Some of them find us. So picture it. A red dwarf maybe, dim enough to hide in plain sight. Or something even colder, a brown dwarf, barely a star at all. Out there right now, drifting through the long, slow bottom of its orbit, getting a little closer with every passing millennium. And every 26 million years, give or take, it leans back in and shakes the comets down on us like fruit from a tree. Here's the thing, though. We looked. When we finally built telescopes that could scan the whole sky in infrared, the kind of light a cold, dim star would give off, we went looking for Nemesis. And NASA's wise survey came back with nothing. No companion, no hidden death twin. And the extinction rhythm itself, the beat that started all of this, turned out to be statistically shaky the harder people stared at it. So most astronomers have quietly let Nemesis go. It's not the leading idea anymore. But notice what it took to kill it. We had to map the entire sky in a kind of light our eyes can't even see, just to be sure there wasn't a second sun in our own house. And the only reason anyone went looking was a graph of dying species that ticked like a clock. The solar system always feels finished to us. Solved. 8 planets, 1 star, everything in its place. Nemesis was a reminder that we've never seen it, and "it isn't there" are not the same sentence. Number 9. The Zoo Hypothesis. The universe is old, almost unbelievably old, 13.8 billion years, and our galaxy alone holds hundreds of billions of stars, many of them far older than our sun. Run the numbers on how much time intelligent life has had to arise, spread, and fill the galaxy, and you get a problem that physicists have been chewing on for 70 years. The galaxy should be crowded. We should see somebody. And we don't. That silence has a name, the Fermi paradox. And there are a lot of ways to explain it. Maybe life is rare. Maybe it destroys itself. We'll get to some of those. But in 1973, a radio astronomer named John Ball offered an explanation that's somehow worse than all of them, precisely because it's so calm. His idea was this: they're out there. They're all around us. And they're choosing not to talk to us. Ball called it the zoo hypothesis. The thought is that advanced civilizations have agreed, across the galaxy, to leave certain young worlds alone, to not interfere, to let them develop on their own, undisturbed, the way you'd protect a wilderness or a nature reserve. We don't hear from them not because they're absent, but because they've deliberately drawn a line around us and stepped back behind it. And once that idea is in your head, it changes the texture of the silence. Because an empty room and a quiet room feel very different. If the galaxy is empty, that's lonely, but it's neutral. Nobody's making a decision about you. But if the galaxy is quiet, if it's full of minds that have looked at Earth and agreed among themselves that we are not to be contacted yet, then the silence isn't absence. It's a policy. A choice that was made about us, without us, by something we've never met. Imagine sitting in a room your whole life, certain you're alone, and then realizing the walls are one-way glass. That everything you've ever done has been visible the entire time, to observers who simply decided you weren't ready to know they were there. There's a real flaw in the idea, and it's worth saying. For the zoo hypothesis to work, every single civilization out there has to play along, forever. All it takes is one of them to break ranks, one curious neighbor, one rule breaker, and the quarantine collapses, and the secret's out. Coordinating that kind of silence across an entire galaxy, across millions of years, is a tall order. And the whole thing is more or less impossible to prove or disprove, which makes most scientists treat it as a hypothesis of last resort. But last resort isn't the same as wrong, and it's telling that some researchers have started suggesting we should stop only listening and start deliberately shouting, just to see if anyone is politely pretending not to hear. The night sky looks empty. The zoo hypothesis just asks you to consider that empty and ignored are not the same thing. Number 8. The aestivation hypothesis. Let's stay with that silence, because there's an even stranger way to read it. In 2017, 3 researchers from Oxford, Anders Sandberg, Stuart Armstrong, and Milan Cherkovich, published a paper with a title borrowed straight from horror fiction. That is not dead, which can eternal lie. And the idea underneath it is genuinely one of the eeriest things anyone has ever proposed about why the universe seems so quiet. The aliens aren't gone, they said. The aliens are asleep. To understand why anyone would suggest something so strange, you have to think about what an extremely advanced civilization would actually care about. Not territory, not resources in the way we think about them. Thought, computation, the ability to run minds, to simulate, to calculate, to experience. And here's the physics that makes this unsettling. The amount of computing you can do with a given chunk of energy depends on temperature. The colder it is, the more thinking you can wring out of every joule. Cold is efficient. Heat is waste. Now, look at our universe. To us, it feels cold and dark. But cosmically, right now, we're living in the warm early morning of everything. The universe is still bathed in leftover heat from its birth. And it is very slowly, over unimaginable timescales, cooling down, getting colder, getting better, if what you want to do is think. So the proposal is this: a civilization that has already grown up, already spread, already gathered the resources it needs, might do the most rational thing imaginable. It might stop. It might gather its energy, build whatever it needs to build, and then go dormant. Aestivate. That word, aestivation, is the summer version of hibernation. Animals that sleep through the heat instead of the cold. And these civilizations would be sleeping through the heat of the entire present universe, waiting for the deep, deep cold of the far future, when the same stored energy could buy them something like 1 trillion times more computation. Think about what that means for the night sky. It wouldn't be empty. It would be a house with all the lights off and everyone inside, sleeping, with an alarm set for an era so distant that the stars themselves will have mostly burned out by the time it rings. The silence isn't death. It's a do not disturb sign hung across the galaxy. And here's the detail that turns the eeriness into something colder. If you've gone to sleep to wait for the perfect future, the one thing you would not tolerate is someone wasting the resources you're saving, or worse, waking you early. Some versions of this idea suggest the sleepers might leave systems running to keep things tidy while they rest, which raises a quiet, awful question about what those systems would do if a young, loud, energy-hungry species started making a mess in the meantime. To be fair, the authors themselves later helped pick apart some of the thermodynamics. It might not actually be optimal to wait. It's a serious idea, not a proven one. But the image never quite leaves you. We keep listening to the universe, expecting an answer. The estivation hypothesis suggests we might just be talking in a bedroom at 3 in the morning to people who are very much there and very much asleep. Number 7. The Medea hypothesis. So far we've been looking outward, asking why the universe is silent. Now, I want to turn the camera around, because the next idea suggests the most dangerous thing in the cosmos might not be out there at all. It might be the thing reading this. It might be life itself. You've probably heard of the Gaia hypothesis, the lovely idea popularized by James Lovelock that life and the planet form a kind of self-regulating system, that the biosphere works almost like a single living thing to keep conditions stable and comfortable, to keep the thermostat set to habitable. It's a warm idea, a motherly one, the Earth as a nurturer. In 2009, the paleontologist Peter Ward looked at that idea and said, essentially, I don't think that's true, and I have the fossils to prove it. He called his counter idea the Medea hypothesis, and the name is a gut punch if you know the myth. Gaia was the nurturing Earth Mother. Medea, in Greek tragedy, was the mother who murdered her own children. Ward's argument is that life is not Gaia. Life is Medea. That life, taken as a whole, is not a careful steward of the planet, but a self-destructive force, one that periodically poisons its own home and drives itself toward extinction. And his evidence is the thing that keeps you up. When you go through Earth's great mass extinctions, the 5 or so catastrophes that nearly ended everything, we tend to imagine asteroids, rocks from the sky. But Ward points out that of all the mass extinctions in Earth's history, all but one were not caused by impacts or outside forces. They were caused by life, by organisms changing the atmosphere, the oceans, the chemistry of the whole planet, until the world became lethal. The clearest example is also the oldest and the largest catastrophe life ever caused. Billions of years ago, the Earth had almost no free oxygen, and then a new kind of microbe figured out photosynthesis and started pumping out oxygen as waste. To us, oxygen is life. To the organisms that ruled the early Earth, it was poison gas. The result is sometimes called the Great Oxidation Event, and it may have been the single biggest die-off in the planet's history. Life invented a toxin and gassed almost everything, including most of itself. That's the Medea pattern. Life floods its own world with something deadly, and the world burns down. And then the survivors rebuild on the ashes, until the next time. Ward even argues that life is, on the whole, shortening the lifespan of the biosphere, hurrying the planet towards sterility maybe 1 billion years sooner than it had to. Now, plenty of biologists push back. Most see Gaia and Medea not as enemies, but as two descriptions of the same complicated truth, and Medea is partly a deliberately provocative metaphor. Life clearly does stabilize the planet sometimes, but the historical record Ward points at is real. Life really has nearly ended itself, more than once, from the inside. And if that's the pattern everywhere, it reframes that cosmic silence we keep circling back to. Maybe the galaxy isn't quiet, because life is rare. Maybe it's quiet, because life, wherever it arises, carries the seed of its own ending. Not as bad luck, as a tendency. The scariest monster in this whole list might not have teeth. It might just be a microbe, doing exactly what it evolved to do. Number 6. The grabby aliens hypothesis. Here's a question that sounds simple and turns out to be a trapdoor. Why now? Why are you here, reading this, in this particular slice of cosmic time? Because the universe is going to keep going for an almost incomprehensibly long time. Stars will keep forming for trillions of years. If you imagine all the conscious beings who will ever exist, spread across that whole future, then you and I showed up shockingly, suspiciously early, like buying a ticket to a film that runs for 1,000 years and finding yourself seated in the opening 60 seconds. In 2021, the economist Robin Hanson and his colleagues built a model to explain that earliness, and the explanation is the kind that makes you sit up a little straighter. They called it the grabby aliens hypothesis. The model splits possible civilizations into two kinds. There are the quiet ones, the ones that stay home, never expand, never make a fuss, and so never get noticed. And then there are the grabby ones. The grabby ones expand, aggressively. They spread out from their homeworld at a serious fraction of the speed of light. They visibly transform whatever they touch, and they don't stop. They grab, hence the name. And here's the move that makes the whole thing work. If grabby civilizations exist, then they're rapidly claiming the universe, volume by volume. The longer the universe runs, the more of it gets eaten up by expanding civilizations, until eventually there's no empty space left for a new one to quietly arise. There's a deadline, a point after which the universe is too full, too colonized, for a fresh young species like ours to ever appear. So why are we early? Because we had to be. According to the model, we exist now, in the universe's youth, precisely because if we'd shown up later, the grabby aliens would already have been here, and this region would have been theirs, not ours. Our suspicious earliness isn't a fluke. It's a clue. It's evidence that the deadline is real, and that the expansion is coming. When Hanson's team ran the numbers, the picture that came out was genuinely chilling in its specificity. Civilizations like this might arise about once per million galaxies. They might already have claimed something like 40% of the volume of the observable universe. And our descendants, if we have any, might run into the edge of one of these expanding empires in roughly 1 billion years. Sit with the shape of that. There may be expanding spheres of alien civilization out there right now, growing at half the speed of light, painting whole regions of the universe in something artificial. And the reason we've never seen them is just that the light from the nearest edge hasn't reached us yet. They're not hiding. They're not asleep. They're simply still over the horizon, and the horizon is moving toward us. It's a parameterized model, and people argue hard about the assumptions, about whether our earliness is really as strange as it looks. No grabby civilization has been seen. This is math, not a photograph. But it's math that took an innocent question, why now, and turned it into a countdown. Number 5. The naked singularity. Everything we've talked about so far assumes the universe has rules. That cause leads to effect. That if you know enough about how things are now, you can, in principle, work out how they'll be next. That's the deepest, quietest assumption in all of science: predictability. The next idea is about a place where that assumption might simply stop being true. Out in the open, where you can see it. To get there, we have to talk about singularities. At the center of a black hole, according to general relativity, matter collapses down to a point of infinite density, a place where the math of space and time breaks down completely, where our equations stop giving sensible answers and just spit out infinities. A singularity. It is, as far as we can tell, a genuine hole in the fabric of physics. But here's the thing that's always made it bearable. Every singularity we know about is hidden. It's wrapped inside an event horizon, the black hole's point of no return. And that horizon acts like a cosmic curtain. Whatever insanity happens at the singularity, whatever breakdown of law and order, it's sealed off. It can never reach out and touch the rest of the universe. The horizon keeps the broken physics quarantined. In 1969, Roger Penrose, one of the great minds of modern physics, gave that comforting fact a name. He called it cosmic censorship. The idea, more a hope than a proof, that nature always hides its singularities behind horizons. That the universe is, in a sense, decent enough to never show us the broken part directly. And then he asked the question that nobody has been able to put to rest in over 50 years. What if it doesn't? What if a singularity could form, or be exposed, with no horizon around it? Naked, visible, out in the open, where its light and its consequences could reach you. That's a naked singularity. And the reason physicists genuinely lose sleep over it is not that it's exotic. It's what it would do to prediction itself. Around a naked singularity, the rules don't just bend. They stop. Anything could come out of it. Particles, radiation, objects, with no cause, no warning, no law connecting what comes before to what comes after. Penrose's worry, in plain terms, was that a naked singularity is a place where the future stops being predictable. Where, if you tried to calculate what happens next, the universe would simply refuse to answer. Imagine looking up and seeing a point in the sky from which, at any instant, literally anything might emerge, for no reason, governed by nothing. Not dangerous in the way a star is dangerous. Dangerous in the way a contradiction is dangerous. A spot where the source code of reality is exposed and corrupted, and we have no idea what it would do. Now, the comforting news. Most physicists believe cosmic censorship probably holds, that naked singularities don't form from realistic collapse, that the curtain always closes in time. A few computer simulations can produce them, but only under fragile, fine-tuned conditions that probably never happen in the real universe. So this is a conjecture, not a confirmed object out there with an address, but it has never been proven. After half a century, with some of the best minds in physics throwing themselves at it, nobody can guarantee the curtain always closes. We're trusting the universe to be decent. We just can't prove it is. And somewhere in that gap between we believe and we know sits a place where the laws end and nothing is watching. Number 4, the holographic principle. I want you to look at your hand. Feel it. It has depth, thickness, volume. It exists in 3 dimensions, obviously, undeniably. Now, I'm going to tell you about a serious idea in physics that suggests that depth, the 3-dimensionality of everything you've ever touched, might be a kind of illusion, a projection. And the truly disturbing part is that this idea didn't come from mystics or philosophers. It came from people trying to solve a very technical problem about black holes, and the math more or less dragged them here against their will. It starts with a strange fact. When physicists worked out how much information, how much disorder, a black hole can hold, they expected the answer to depend on its volume, on how much space is inside. Bigger inside, more room for stuff. That's how everything else works. A bigger box holds more. But that's not what they found. A black hole's information turned out to depend on its surface area, on the size of the 2-dimensional boundary around it. Not the volume inside. The skin, not the body. That should not happen. It's as if you were told that the number of things you could fit in your house depends only on the area of the walls, not the size of the rooms. And it sent a couple of physicists, Gerard 't Hooft in 1993 and Leonard Susskind 2 years later, toward a conclusion that sounds insane until you trace the steps. The conclusion is the holographic principle. The idea that everything happening inside a region of space can be completely described by information stored on the boundary of that region. The three-dimensional inside is not the fundamental thing. The two-dimensional boundary is. The inside is the projection. You already know what a hologram is. A flat piece of film, two-dimensional, with a pattern etched into it that throws up a three-dimensional image when you shine light through it. The image looks solid. It has depth, but all the real information lives on the flat surface. The depth is encoded, not fundamental. The holographic principle takes that idea and points it at the entire universe. It suggests that everything you experience is three-dimensional. This room, the stars, your own body, could be the projection of information painted on a distant, two-dimensional surface, somewhere out at the edge of reality. And here's the part I have to be honest about, because it's what makes this more than just a trippy thought. The mathematics works. In 1997, a physicist named Juan Maldacena found a precise, concrete example, where a universe with gravity in three dimensions is exactly, mathematically equivalent to a description with no gravity living on its two-dimensional boundary. Two descriptions, same reality, one with depth and one without. It's become one of the most studied and trusted ideas in theoretical physics. Not because anyone wanted reality to be a hologram, but because the duality keeps turning out to be true. The careful caveat is that the cleanest version of this works in a kind of universe that isn't quite ours, a particular geometry of spacetime that doesn't perfectly match the cosmos we actually live in. So we can't say, flatly, that you are a hologram. Not yet. It's a profound mathematical truth that we're still learning how to apply to the real thing. But pause on how we got here. We didn't go looking for this. We were just trying to figure out where information goes when it falls into a black hole. And the answer that came back, quietly, from the equations, was that maybe the depth of the world is a story the boundary is telling. Reality might have a surface, and we might be living on the inside of the picture. Number 3, the block universe. Of everything on this list, this one might be the hardest to shake, because it doesn't come from some exotic frontier of physics. It comes from the most successful, most tested, most boringly reliable theory we have. Einstein's relativity. And what it quietly implies is that the flow of time, the thing you are experiencing at this exact moment, the sense that the future is open and rushing towards you, might not be real. Start with something Einstein proved over a century ago. There is no universal now. This sounds abstract, so let me make it concrete. Whether two events happen at the same time depends on how you're moving. Two observers, moving differently, will genuinely disagree about which of two distant events came first, and neither of them is wrong. Simultaneity, the idea of a single shared present moment ticking across the whole universe, simply does not exist in relativity. Your now and someone else's now can be tilted relative to each other. That sounds like a harmless technicality. It is not. Because follow it through. If you are moving, even slightly, relative to some distant being far across the galaxy, then your now slices through their timeline at an angle. Your present moment could line up with what they consider their future. And if you turn around and move the other way, your now could line up with their past. The events in their future, from your point of view, are already fixed, already sitting there, already as real as anything in your past. And here's the trap closing. If their future is already real from your perspective, and somebody else's future is already real from theirs, then logically every moment, past, present, and future, must all be equally, fully real. All at once. Not unfolding, not becoming, just existing. This is what philosophers, building on relativity through arguments laid out in the 1960s by Reitdijk and Putnam, call the block universe. Eternalism. The idea that the universe is not a movie playing forward, but a finished, four-dimensional sculpture. Past and future are not gone and not yet. They are just elsewhere. Like other rooms in a house you happen not to be standing in. Take a breath, because here's what that does to you. If the block universe is real, your entire life, every moment of it, your birth, this exact second, your death, all of it already exists, complete, out there in the block. The you of 10 years from now is as real, right now, as the you reading this. You are not moving through time. You only feel like you are, the way each frame of a film feels like the present to the characters inside it, even though the whole reel already exists. Every frame printed, the ending is fixed as the beginning, which means the future isn't open. The decision you think you're about to freely make is, in this picture, already there in the block, already made, already part of the sculpture. Free will, the sense of authoring the next moment, becomes a feature of how it feels to be a slice of the block experiencing itself in sequence, not a power you actually have. Now, this is contested, and I want to be fair about it. The philosopher Howard Stein and others have argued the logical leap from relativity to a fully fixed future contains a subtle fallacy, that frame-dependent simultaneity doesn't quite force a frame-independent block. Other views of time are still alive. Physics tells us how the universe behaves, not, with certainty, what it ultimately is. But the unsettling thing is how natural the block universe falls out of physics we already trust completely. You don't have to add anything weird. You just have to take relativity seriously, all the way down, and you arrive at a universe where time doesn't flow and your future is already written. The next moment feels like it hasn't happened yet. The block universe just asks you to consider that it always has. Number 2, the simulation hypothesis. You knew this one was coming. It's the idea that's escaped physics and philosophy entirely and gotten loose in the culture, the one everyone's heard some version of. That this, all of it, you, me, the stars, might not be real, might be a simulation. And because it's everywhere, it's easy to wave it away as a stoned dorm room thought. But the actual argument, the serious one, is much tighter and much harder to escape than the pop culture version. And it doesn't ask you to believe anything mystical at all. It just asks you to count. In 2003, an Oxford philosopher named Nick Bostrom published a paper called "Are You Living in a Computer Simulation?" And he did something clever. He didn't try to convince you that you're in a simulation. He laid out 3 possibilities and argued that at least one of them has to be true. This is the part people always get wrong, so stay with me. Possibility 1. Civilizations almost always destroy themselves before they get advanced enough to build truly realistic simulations of conscious beings. They wipe themselves out first. Game over. No simulations ever get made. Possibility 2. Civilizations do reach that godlike level of technology, but for some reason, almost none of them ever choose to run these simulations. They could create whole worlds full of conscious minds, and they simply decide not to. Across billions of civilizations, basically all of them, all the time, choose not to. Or possibility 3. Some civilizations get that advanced, and some of them do run simulations. And here's where the counting becomes a trap. Because if even one mature civilization runs these simulations, it wouldn't run one. It would run thousands, millions, whole histories, populated by countless simulated minds, over and over. And once you allow that, the number of simulated conscious beings absolutely dwarfs the number of real, original, flesh and blood ones. The fakes outnumber the originals 1,000,000 to 1, or far more. And now ask yourself the only question that matters. If simulated minds vastly outnumber real ones, what are the odds that you, specifically, just happen to be one of the rare real ones? Statistically, you almost certainly aren't. You're one of the many, not one of the few. So if possibility 3 is true, you are right now almost certainly inside a simulation. That's the trilemma. Either civilizations die before they can build it, or they can build it and choose never to, or you are probably living inside one. There is no comfortable fourth door. Bostrom's point was never you are simulated. It was that you have to swallow one of those 3, and look at them, really look. The first says our future is doom. The second says every advanced species, without exception, exercises a restraint we can barely imagine. The third says the ground under your feet is code. What makes this one land harder than all the others is that it's not about the distant universe. It's about the realest thing you have, the feeling of your own existence, the weight of your body in the chair. And the argument doesn't even need the universe to be fake to disturb you. It just needs you to notice that the math of large numbers doesn't care about how solid the floor feels. The skeptics have real objections. Maybe consciousness can't run on a computer at all, no matter how advanced. Maybe simulating a universe convincingly is impossibly expensive, even for a godlike civilization. And in its strongest form, the idea can't really be tested, which makes a lot of scientists uneasy about calling it science at all. Those are fair. This is an argument, not a measurement. But the next time everything feels unmistakably, undeniably real, remember that it feels real is exactly what it would feel like either way. The simulation doesn't have to be perfect. It only has to be the only thing you've ever known. Number 1, the doomsday argument. We've traveled a long way. Hidden stars, sleeping aliens, the breakdown of physics, the idea that reality is a projection or a recording or a program, and every one of those required you to accept something exotic. A second sun, a galactic conspiracy, a naked singularity. A line of philosophy stacked on top of relativity. For the last one, I'm going to take all of that away. No aliens, no new physics, nothing strange about the universe at all. Just numbers, and you, and a conclusion so simple and so cold that physicists have been arguing about it for 40 years, precisely because nobody can cleanly make it go away. It's called the doomsday argument. It was first laid out by the astrophysicist Brandon Carter in 1983 and developed by the philosopher John Leslie. And here's the whole thing, the entire engine of dread, in one idea. You are not special. Let me show you what that does. Imagine writing down a list of every human being who will ever live. Everyone who already has, everyone alive right now, and everyone who ever will, all the way to the very last human, whenever and however that happens. Number them in order of birth. 1, 2, 3, on and on. Somewhere on that list is you. You have a number, your birth rank, your position in the entire human story. Now, the only assumption, you should expect to be roughly typical. Not the very first human, not the very last. Just somewhere in the unremarkable middle of the list. This sounds almost too obvious to bother saying. If you're a random sample from a group, you're probably not at the extreme edge. You're probably in the bulk. Here's where it turns. Roughly 100 billion humans have been born so far across all of history. That's where your number sits, somewhere near the front of that 100 billion plus count. Now picture the hopeful future, the one where humanity spreads to the stars, colonizes the galaxy, lasts for millions of years, and produces not 100 billion people, but 100 trillion, 1,000 times more. Maybe more than that. But wait, if that vast future really happens, then you, sitting here near the first 100 billion, would be among the earliest tiny sliver of all humans who will ever live. You'd be in the opening fraction of 1%. You would be deeply, wildly atypical, right at the very start of an enormous list. And the argument says that should make you suspicious, because being that special, that early, is exactly what you should not expect to be if you're just a random human. Flip it around, and the cold conclusion appears. The fact that you find yourself here, among the first 100-some billion humans, is much more likely if the total number of humans who will ever live is not 100 trillion, but something closer to what we've already had. Which means humanity probably does not have a vast, galaxy-spanning future of trillions. It means we are probably much closer to the end of the human story than to the beginning. Leslie himself put real numbers on it, estimating something like a 30% chance of human extinction within the next 500 years. And notice what just happened. I didn't show you a threat. There's no asteroid in this argument, no war, no plague, no collapsing vacuum. The doomsday argument doesn't tell you how it ends. It just takes the single most ordinary fact about you, that you exist now, at this moment, with this birth rank, and turns that fact itself into evidence that the end is not far off. Your own existence becomes the warning. Now please hear the other side, because it's real and it matters. This argument is fiercely contested. Critics say it misuses what it means to be a random sample, that the very idea of treating your birth like a lottery ticket drawn from all of history is subtly broken, that the group you're supposedly sampled from isn't even well defined. Plenty of brilliant people consider the doomsday argument a beautiful puzzle, a flaw in our reasoning waiting to be found, rather than a true prophecy. I lean toward thinking they're right. I hope they're right. But here's why it belongs at the very end of this list, why it's the one I'd leave you with. I'd leave. Every other idea we've explored tonight points outward, at the cosmos, at its silences, and its broken places, and its hidden depths. This one points at you. It says the strangest, most unsettling object in the entire universe might be the simple fact that you are here, now, reading this, at this particular moment in the human story. Not in the deep past, not in the far future. Here. And whether that's a meaningless coincidence or a quiet, statistical alarm bell is something none of us can truly know. We spend so much time staring out at the universe, frightened of what might be out there in the dark. Maybe the most chilling theories were never really about the dark at all. Maybe they were about the strangeness of getting to be here to look. A brief window of awareness, somewhere near the middle of a story we can't see the end of, in a universe that has never once promised to make sense to us. And the only honest response to all of it, to the hidden stars and the sleeping minds and the math that says we're early, isn't terror, it's attention. Because if any of this is right, then this moment, this exact one, is rarer and stranger than we will ever fully understand. Thank you for watching and sticking till the end. We've got plenty more videos coming in the future. Hit that subscribe button so you don't miss them. See you in the next one.